Andrei Konovalov, and I am an assignee from Texas Instruments in the multimedia working group. One of my main activities is maintaining open embedded builds for this group, and this is mostly this presentation is about. It's not kind of tutorial of how to use Open Embedded, but what we do with Open Embedded in our working group. MMWG builds are based on reference platform builds. Since last connect, the status of reference platform builds has a bit changed, so this is more like a community effort now, and as long as people continue to work on them, to submit their changes, they will continue to run, and that's perfectly fine for our working group, so we continue to use these builds as the basis for ours. We use one extra layer compared to reference platform builds. Meta-Ihg contains the components developed in MMWG, and those components that are not in reference platform builds but which are needed to get the features we need in our builds. The builds are running in Jenkins, and they are published to snapshots. Actually, it's a question for me if someone uses the pre-built images we are publishing for their work, because my feeling is that our builds are probably more useful for developers as a setup they can use for their development. Maybe the pre-built images are not that valuable, but we need them anyway because this is the way to run the tests in Lava, and we submit the tests via QA reports, and this let us see the test results and some statistics at QA reports. For the moment, we show only the statistics for and results for the multi-builds, but I plan to add Rocco builds to be visible at QA reports as well. This is the matrix of all the builds we are currently doing. We still actively use multi-release, and also there are Rocco builds and two other builds which stand separately. I'll go to them in a while. We only do Western builds because we're not that interested in X11, for example, at least in the short term. And the boards we use are TI's AM57XX EVM, Dragon board 14C, Meta-Ihg, and IMX8 we plan to add it shortly to our builds. Most probably we'll start with Rocco. The two other builds are for play ready, and these builds play ready is not publicly available in source code, so I cannot say much about it. And the last one is the build which has Westeros and WP instead of Western and Chromium. It only supports 32-bit targets, so that's why it's for high-key 32-bit. Sumo builds we plan to edit someday, but not in short term, because mostly the reason for that is because we use BSP layers from which provide support for the bots, and for the TI and IMX8 bots, we don't have releases for Sumo yet. As soon as they appear, we can start doing Sumo builds as well. For example, reference platform builds have Sumo already. So as for the why we need a builds of our own is because the areas multimedia working group is focused on are about CDM and OpenCDM in particular, security data path implementation. And this is what reference platform builds don't have, for example. So to work with CDMs, we need few key components like Wayland with Western or Westeros as a compositor, Opti. To test OpenCDM, we use browsers like Chromium or WP browser, and the CDM implementation we have in those builds is Linaro OpenCDM, and also we have play ready, but it uses a protected Git repository as it's not open to the public. We're also interested in hardware accelerated video, and this is again Wayland Western, and currently we work with GStreamer. There are boards which have everything required for hardware acceleration in open source and publicly available from GitHub, for example. This is the case of Dragon boards. For the TI board, TI has their own open embedded distribution, which have all the software required to enable hardware acceleration on their board, and we use this in our builds. And one area we will start working on is upstreaming the patches used in TI's layer for GStreamer. So we can use MMWG builds as a test bed for those patches as well. Actually, I've told about the structure of Meta-Ihg at the previous connect, and there are no changes here. It consists of 3 layers, the most important one being Meta-Ihg layer. This is where the software MMWG works on live. Here is the Chromium PB append, which enables OpenCDM for Chromium and CDMI and the Opti implementation, which is needed for OpenCDM. There are also images which include OpenCDM, or in case of there are images with Chromium and OpenCDM, and image which has WP lives in its own layer, which is the last one listed here. Also, sometimes it's not possible to use third-party layers directly when we need support for some, for example, for hardware acceleration for some of the boards, and in this case we have to just pull the recips from vendors' layers into our build, into our layer, and this is a separate layer which is called Meta-Ihg integration. In the ideal world, this layer should not be used, and we try to keep it as small as possible, but it's not empty. As we use Opti to implement CDMs, we need the boards which have Opti support usable for us, and at the moment this is only one board, Meta-Ihg. It's most actively used at the moment. The disadvantage is that it's out of production and it's not easy to get one. So we are considering moving to other boards which support Opti. There are 2 of them available right now. AM57XX CVM has a high security version. The problem with this board is that all the sources are publicly available, but to build an image which could be used on a high security board, one needs to have the security tools to sign the images and to create them, and these tools are not publicly available. For this reason, we cannot do builds in Jenkins, and without the images we could not run tests in Lava. I'm not sure if it would be okay to upload the images manually, but anyway, this is not what we are looking to implement the CI loop. So the NXP's IMX8 board looks more promising in this sense. It has an SDP implementation already, but not for Linux. And adding this board to MMWG builds is in progress. Until this is done, the developers use the J release for IMX8, which is available from NXP and is completely open. Just it's not RPB based. It's based on NXP's own distribution. So far, as we had only high keyboard with Opti support and the builds until now, we didn't face a kind of problem with the Opti versions. So the left column for high key shows what Opti versions are supported in a Meta-Ihg layer, which is used, for example, in reference platform builds as well. And the Opti releases there are not very recent. They correspond to the current release of Opti at the time when the corresponding reference platform build was set up. And if we look at the vendors OpenMBG distros and check the Opti versions there, we will see that the situation varies depending on what vendor we are looking at. TI have Meta-Ihg distro, and for Moti they use 2.6.0. For Rocco they use pretty recent 3.1 release. And in case of IMX8, Opti version 3.0 is used for both Moti and Rocco, but actually it's not the Linaro releases, and both TI and NXP added some patches on top of what was released in Linaro. In case of TI, the difference turned up to be pretty small, and as far as I could see, for Rocco they use just a snapshot of Linaro's tree, even though they have a repository of their own for Opti. I speak about OptiOS in this particular case. And NXP did more changes to Opti. Actually, one of those changes surprised me quite a bit. The first change to OptiOS code was to remove most of copyright text from there. I'm not sure why this was done, but so if you look at those versions, it's pretty obvious that it hard, if not even possible, to have these versions, these exact versions in a single build. So while we are adding IMX8 to our builds, I plan to experiment with Opti versions, and I hope that using just the recent enough Opti version would be okay for all the boards. I would do my best to avoid using different Opti trees for boards in single build. I just don't see any advantages of doing that. Maybe I will have to keep the patches for IMX8, for example, separately, but I would like to have the common base for Opti for all the boards in one build. I think at last connect we already moved Rocco builds to Chromium version 65, and this was using the work done by Igalia. Why version 53 is special is that this is the last version which used GIP building system, and after this version, all the version past 53 don't have GIP support, and Open Embedded Meta browser Open Embedded layer didn't have support for GN for quite a while. It was added for X11 builds, and I think by Intel, and for Wayland it was Igalia who did most of the work, and we use their recipe with some minor modifications. Actually, Igalia updated the Wayland Chromium recipe in upstream Meta browser, but it uses version 64, which didn't quite work for me, and I tried the next version and it works fine, so that's why we use version 65 in the Rocco builds. What I'm not happy with is that upstream Meta browser has the X11 recipe updated regularly, like every week or two. So the X11 recipe for Chromium is up to date and uses a recent Chromium release. But for Chromium as on Wayland recipe, nothing changed since December 2017. I've actually posted a patch to Meta browser updating Chromium was on Wayland for a more recent version, quite some time ago, maybe more than half a year ago, maybe even earlier. And I mentioned that this is mostly Igalia work, which I'm posting, and Igalia replied, and they said that they do plan to update Chromium on Wayland recipe in Meta browser, but this didn't happen. But Igalia is still actively working on Chromium on Wayland. They use it for their own development, and they have a meta browser layer which have the Chromium recipe for version 70, if I recall correctly. We could follow their work as well. It's just a pity that they didn't find the time to upstream their meta browser work, and we can just use what they provide in their meta browser layer, and they also publish Chromium tables with their modifications for Wayland at least twice a month. So the recent Chromium for Wayland is available, it's just not in upstream meta browser. Being more close to the current release of Chromium has the obvious advantage of getting some recent additions like HDCP support in MMWG builds. What changed since the last connect is that we finally put forward our OpenCDM solution from Chromium version 53 to 65. It was mostly about updating our OpenCDM to use Gen build system and to account for changes in CDM code in Chromium itself. So now we just keep OpenCDM in sync with changes done to Chromium's clear case CDM implementation, and it currently uses CDM version 8, sorry, version 9. So it's not the most recent, but quite close. Due to the changes in CDM implementation in Chromium, we've created a separate branch for OpenCDM, which would work with Chromium version 65. If you look at open content, so if you look at OpenCDM repository at Linaro MMWG account in GitHub, there are branches they're named, which names has the exact Chromium version that are intended to work with. The 65th version currently misses recent additions to version 53. These are unification with WP. This unification means that the same code could be used to build the OpenCDM library for both Chromium and WP browser. OpenCDM for version 53 also supports PlayReady, and I haven't ported it forward to version 65, and the main reason is that I don't have access to PlayReady sources, and I just could not verify if the forward port is done correctly or not. So this adding PlayReady is one of the to-do items for OpenCDM for version 65. The builds and Jenkins has already took this change, so now we have OpenCDM enabled for hierarchy in Rocco builds as well. The Moti builds will continue using Chromium version 53, mostly because there might be some work which depends on this particular version, and breaking it wouldn't make any sense. So the to-do list for OpenCDM for Chromium version 65 is adding PlayReady support, putting forward unification with the WP browser, and there is a feature that to the version 53 of the OpenCDM plugin, which would make it possible to build debug version of the plugin while building a release version of Chromium. This is quite useful for debugging, as building debug version of Chromium is not the easiest way to work. The resulting image would be quite huge, and it would be not easy to use it. But due to changes in the build procedure, this change cannot be moved as is to gen build, and that's why this feature disappeared while updating to version 65. Re-adding it would be a good thing. So this is in to-do list. I can't say much about Westeros WP build status. Other than that, there is a Jenkins build for this configuration, and it's not building at the moment. So I'm in process of updating it, and hopefully it will be working soon again. For WP, there is a more recent WP has support for a more recent version of EME, more recent than version 0.5b, and in MMWG we do work with EME version 3, but it needs more work to get it enabled into MMWG builds. I can't say that we have a full operational CI loop for our open embedded builds, but what we have is that there are builds for both Moti and Roku which run periodically 3 times a week, and the images built are submitted for testing in Lava. Just we don't have all the target boards in Lava at the moment. We can use high keys, and for high key we do submit testing jobs. Dragon boards should be available as well. The thing is that for our tests we need the boards in Lava to be connected to some kind of HDMI monitor or a dummy dongle which simulates the presence of HDMI monitor, and it's not strictly required, but it's easy if mouse is also connected. Not all the boards have HDMI dongles connected, so not every board in Lava is okay for our testing. There are Dragon boards in Lava. We don't use them at the moment. And it might have sense to use them for our tests as well. The thing is that we don't have anything special in our builds for Dragon boards, so we can use them mostly for sanity testing as reference platform builds, and the builds which Qualcomm landing team is doing, they have all we have for Dragon boards in our builds. We don't have any added value. The last AM57XX EVMs should be available in Lava. They are mostly used for Android testing, I think, and we haven't considered using them for our testing yet, but probably this would make a sense to try using them as well. IMX8 boards are not fully enabled in Lava yet. They are present, and the work to make them available in Lava is underway, but there are still some problems due to firmware for those boards, so they are not yet fully functional in Lava. But quite possible that by the time we will add IMX8 to our builds, these boards will be fully operational in Lava, and then we should use them. Here is the list of the tests we run. For Opti, we use standard X tests. We also do a test for EGL support in Western, just because Chromium would not work if EGL doesn't work. We also have a few tests for GStreamer, which is playing a video file in the tests we submit from the Jenkins job. We only have one test case. In manual testing, we also have an option to use software decoding or hardware accelerated decoding. But anyway, it's not a comprehensive test for GStreamer, just basically one test case, one use case. For Chromium, the tests for Chromium also originate from manual tests. That's why there are just 3 simple test cases, except for just starting the browser. We also have playing a video from YouTube, a WebGL test which uses an example from 3GS.org website, and we have a EME test which records a video using ClearK. And Arthur Shea from our working group created a test definition which uses OpenCV to recognize the image when a video is playing back, and it uses it as a criteria if the test is okay or failed. But again, this is just a few use cases which doesn't explicitly test every protocol flow of CDM and every API. So we definitely need some enhancements in how we do testing. The low-hanging fruit is that builds and baselines did kind of sample job we can use to enable to trigger a build when a commit is done to OpenCDM or OpenCDMI. This needs to be a bit reworked because it was created when we have only one branch and one version of OpenCDM. Now we have a separate versions for Chromium version 53 and 65, and we will need 2 different triggers for that. We need to filter the changes which happen to the Git repositories that trigger is looking for. But this could be done in a week or so. We need more tests, more comprehensive tests, like GST validate for GStreamer, and there is a test inside Chromium source tree, and OpenCDM has its own version of this test set, but it doesn't correspond to the current version 65 of their browser and of the Chromium browser and the OpenCDM plugin, so it needs to be updated, and then we could try using it. This would let us check the whole implementation of OpenCDM instead of just one particular use case. Another side of the problem is that if you look at the test results at query pods, they're not very easy to compare, and there is a possibility to use kind of filters. So there is a way to show graphically the changes between builds one is interested in. There is such a possibility in query pods. We don't use it yet, and this is what is worth looking at. From the hardware point, there is a new, more or less new device by Google, which is called Chromium, and it can be used to verify the actual output signal which comes to the HDMI connector, instead of taking the screenshot from the web driver for Chromium like we currently do. So this is not another way to enhance the coverage, and this is another option to consider. So I think this is all I have. As always, LG OE manifests has the instructions on how to do the build. So if someone is going to reproduce those builds, this is the way to start looking from. So, any questions? Okay. So, if there are no questions, you can consider this session done. Thank you.